Hi everyone, my name is Ryan Fuller and I'm a mechanical design engineer for this small aerospace company, Northrop Grumman. In my job, I use tools like physics, calculus, and memory recall to design tools for aircraft maintainers to use when working on an airplane. Think of an airplane version of a really good car mechanic. So one of the coolest things to me about my job is that every day I get to do different things. One day, I might create a 3D model. The next day, I might create the manual to teach people how to use it. Or another day, I might present a design to a customer or even travel on site to test a piece of equipment that I designed. I'll get into more of what I do later, but let's talk about how I got here really quickly. So I was born in Little Rock, Arkansas, and moved to Georgia for college. When I was growing up, I stayed in trouble for taking my toys apart. Thankfully, my mom was pretty attentive, and after whipping my butt for messing up my toys, she put me in science and math workshops and camps. I hated it at first, but by the time I got to middle school, I was pretty good at math and in science, so I guess it paid off. What made me want to be an engineer was the combination of two teacher stories. One teacher, my physics teacher, and the other teacher, my orchestra conductor. Yeah, I was an orchestra kid, and while it may not have made me the most popular, it did help me earn a partial scholarship to college, so I guess it was worth it too. But back to the story. Their stories were most influential because they described two different lifestyles from both, and one of them cemented my career path. The physics teacher described a stressful but financially stable lifestyle that afforded him the opportunity to support a family. Our orchestra conductor described a life that was a little less stressful, but also not as financially stable, and he was not able to support a family the way that he desired to. I knew I didn't want that life. And for me, I was pretty good at physics, so I decided that I'd try this engineering thing. So my senior year of high school, I applied to Georgia Tech, and I was admitted. From there, I worked in a few different internships. I graduated, and after several different roles, I was able to develop into a principal engineer, which is a fancy way of saying that I'm trusted to lead a design team to accomplish a goal. Okay, so remember earlier I talked about how we come back to what I do every day, right? Well, now it's time to do it. So picture this. You're the head of a design project and you're in a meeting with the customer. Somebody fancy, think of the big suits, or honestly for us sometimes slacks and a polo, but whatever. The customer wants to design a solution to this challenging lifting problem. In our world, we call that hoisting. It means pick it up from above. So here's how that process would look. So step one, you're going to collect information. That means you may have to look up things or Google things or call people or talk to people that work on whatever it is. In this case, we're going to pick up the plane. Okay? So you're talking to the maintainers. Step two, we're going to combine all of the information and we're going to determine what's important and what isn't. Because sometimes you'll learn in these processes, you'll get a lot of information and some of it isn't very helpful. But that's cool. That's why you do the step. Step three, you're going to come up with an idea that you'll walk with the customer through. We call this a conceptual design. And in this, the main thing is to get the idea out of your head, show it to them, be as creative as you want. Maybe you're just going to have, pink and green, blue and white. I'm kidding. But whatever thing you put in that, you get to use your creativity here. It's another really cool part about the job. And now you want to get their approval, get their sign off. Then we're going to get to the real work. Step four, we're going to go and do all of our modeling. We're going to do all these calculations and all this math and draw all this stuff on the whiteboard. And you also kind of get to message your coworkers and maybe you're going to go out to lunch and all this other stuff in between. But the whole time you're thinking, you get paid to think. It's a pretty cool gig. After you do all the stuff that you need, you're going to come to step five. Step five, you're going to make this drawing package. That's a fancy way of saying you're making the assembly instructions. Yes. When you go to the store and you buy something, you open the box, that package that you use or that you read that tells you step one, screw the screw in there. You're going to make this. That's you now. You're going to tell everybody how to do this so that when they get it in the shop, they're going to pull this thing open and say, all right, this is what I'm going to make. So now we're at our very last step. So last step, you've completed your design. Every part has been created, or we say manufactured in this world. And now it's been assembled. You get to go play with your creation. This is called testing. So now you're going to test your equipment with the customer. They smile. Everything's great. They've paid you because you do have to get paid. And then that's it. You just created your first engineering design. Seems really simple. The steps can have their hiccups, but the important part here is, as an engineer, you are creating solutions to everyday problems. In this case, we're picking up an airplane or a piece of an airplane, but in some worlds, some engineers are solving hunger for different groups. Maybe somebody needs clean water. Maybe somebody needs power. Maybe somebody needs some way to carry books, and how we got things like backpacks. So really, engineering comes down to this really simple concept of solving a problem. You're going to use what exists out there to solve some problem, or you may stumble on some new creation. And then that's how you get into some of your great inventors. All of these things are part of engineering design. So on that note, I want you to think about something. As you're leaving this presentation today, I hope I didn't put you to sleep. And I'm hoping as you leave, think about the problems around you. Think about something that's challenging to you, and maybe you have an idea for it. Maybe you have a solution.
All right, here's your chance. Now let's think about any problem. There's no problem too big. There's no problem too small. Anything that you can solve. Maybe you can fix it. Maybe you can make it better. Keep going. You're almost there.
I do believe that in this class right now, listening to this video, are solutions to some of today's problems. They're in your brains. We need those. So hopefully some of you will take on the challenge and you will think about being a scientist, being an engineer, solve some of those problems and make the world better. So hope you enjoy it. Talk to you guys later. Have a good one.